Okay, thanks. So we're going to discover some properties of sine, cosine, and hopefully it's the graphs of those functions and lead into the graph of tan as well. That's the goal for this lesson. But also a reminder that this shouldn't take too long. I'd say probably by maybe our double lesson on Friday, we're starting our next topic, which is graphing. So for those of you who don't have a graphics calculator yet, this is probably when it starts kicking in, and using the graphing section of our calculator can be helpful. So put a little speed on trying to get one of those if you want to. Also, we've got a common test this semester. So that'll be in week, I want to say 10. No, 9. Week 9, you will have a common test. It'll just be on three topics. Definitely trigonometry, probably some algebra, and then the graphing stuff that we'll do. Okay, so just keep that in mind to make sure that we're nice and organized. Ready? What I'm going to ask you to do is, using your diagram here and your geoliner, I'm going to hopefully ask you to complete this sort of table. And as you can see, we've got quarter circle. What's the radius of our circle? 1. Beautiful. And the first thing that we are going to do, the one that I've got here, if you can measure it, so let's all check that you know how to use your protractor and geoliner. So those with the geoliner, you put the straight edge along here. So you'll put the geoliner straight edge there. You've got that sort of going along like so. And you can see along here you've got your little measurements, 10, 20, 30, 40. And you should be able to measure what that angle is. Those with the protractor, you will have the round. Oops, that's not very good. You will have your round circle. You put your center right there. And it's like a little magnifying glass, protractor people. That little round thing in the middle, little magnifying glass. You lift it up. Anyway, and you will put here your 0 degrees. So protractor, we've got people with protractors, we've got people with geoliners. So protractors, 0 degrees here, and you should read off what the angle is. So on the count of 3, bless you, what do we think that angle is? 1, 2, 3. 30. Correct. So it's 30 degrees. If you didn't understand or see why it's 30 degrees, in a minute when I stop and you're doing your thing, put your hand up and I'll come and show you how to use it. So here's one of the important things to realize, is that when we're looking at this thing to see how we get our graphs of our sine and cosine, our x-axis is our cos theta. Our y-axis is our sine theta. So to complete this first question here, sine of 0 is what? So, well, actually, I'll do it for 30. That might make sense, and we'll come back and do that one later. So sine 30, you're going up here. We see the little triangle that it makes, and we're reading off the y value. So you go over here and you go, well, what would that be? 0.5. And we put, what do you think? So to get the cosine value, we have to read down here. What would cosine of 30 be? Now that's 0.8, this is 0.9, 0.87. Do we agree? And you have to basically go through and fill this out. Okay, so when it now comes down to sine of 0, well, where would sine 0 be? That's actually all along here. Agreed? So what would be my y value? How high has it gone at this point? Right, hasn't gone anywhere, it's 0. What would be my cosine? So sine is vertically, cosine is horizontal length. Does that make sense? Okay, so now you get your geoliner out to do number 10. You will measure your 10 degrees, drop it down, read it off, and fill out both. Does that make sense? Sine, as we said, that's your vertical. And cosine is your horizontal. So that shouldn't take too long. Let's give it a crack. As we said, when we've got this, every point, so this coordinate here, if we were going back to the whole x and y, we would agree that this would be the coordinate x, xy, yes? But what we're now doing is we're viewing our x coordinate as the cosine. So any point on here is actually cos theta, sine theta, agreed? And so when we're using this coordinate system, we can say that this point here then, because our angle is 30, we're saying that this coordinate is cos 30, sine 30, and then from your stuff that you've done, we can say, well, this is actually 0.5 and 0.87. Yeah? You think, yeah, well, that's a bit obvious. I mean, what we're saying then is that cos 30 equals 0.5, sine 30, what have I done? I've done it the wrong way around. And that's on video. How embarrassing. And you didn't stop me. So 0. That's because I've put sine on the left, cos on the right. I should have switched it, right? So sine is 0.5, cosine is 0.87. Got that? That wasn't done very well. Anyway, onward. What I'm going to ask you to do is, once you finish that, is I want you to now see, can we actually get all of the degrees and all of the values for sine, cos, tan, sine and cos of all of these different degrees around the circle. So it's a little bit wacky, but they're all meant to be, that's 30, that's 60, 45, and this one are symmetrical. Yeah? Doesn't look like it on my diagram, stuffed it up a little bit. So for this one, we just put that down. That was 0.87, 0.5. Remembering, every coordinate here is cos theta, then sine theta. So what would this angle here be? So that's going up there 30. This is coming back by 30. And as everyone figured out, this goes 0 degrees. We've got 90 degrees, 180, plus another 90, 270, then we come back to 360, yeah? Going around the circle. So what would this angle here be? 150, correct? Okay, that's 45. We're coming up here 45, so what would that angle be? Very good, took you up. 180, take 45, that's 135. And again, you're going, what is going on? Wow, here it comes. You should be able to, by just looking at this, you should be able to tell me what cos of 150 is and what sine of 150 is without touching your calculator. So these are symmetrical. So how high is this one going? How high on my... So how high did this one go? 0.5? So do we agree this one is also 0.5? Okay, and what about this one? This is your x coordinate here. So how far out did it come this way? Good, negative 0.87. I didn't leave you enough room to write those there. So let me just pause. Saying from this is that we believe that cos of 150 is negative 0.87, and we think that sine of 150 is 0.5. Agreed? Let's have a look. What's sine of 150? You superstars. What's cos of 150? Oops. Well done, well done. So without using a calculator, you got that correct. Agreed? Do you think there's another angle that you could tell me sine and cosine of that angle? What would this angle be? Remember, hang on the angle first. They're symmetrical. Doesn't look like it from my diagram, but symmetrical. So 180, instead of taking 30, we are now adding on 30. So do we agree it's 210? Yes? So what do we think? Remember, this is your cos. What do we think cos of 210 is? Negative 0.87. And what do we think, I'll put it there, negative 0.87. And what do we think sine of 210 is? Negative 0.5. Let's see how good you are. Sine of 210. Correct. Cos of 210? Correct. So they're not just freaky little numbers that come up on your calculator. It's all about symmetry on the circle. Yeah? Once you've done that, what I'm going to ask you to do, so this is why I don't have to keep interrupting you all the time. So you want to complete that first quarter circle. I would like you to complete this circle here. And then I want you to take and focus on your sign values. Okay? So at this point here, what's that coordinate, by the way? 1, 0. That's right. So remember, this is your cos. So that's cos of 0, and this is sine of 0. So sine of 0, sine of 0 is 0. So we pop that there. What's sine of 30? A half. We pop that there. You will figure out what sine of 60 is, and you'll plot that there. What's sine of 90? What's that coordinate right there? 0, 1. So sine of 90 is 1. And then you'll plot the points, and with a smooth hand, you will connect the dots. Okay? That's your goal. I give you like 10 minutes. Okay, so Ella, just to make sure that you understand, because I did that a bit quickly, but if you look at this triangle here, it's reflecting with this triangle here, okay? And because we now know this coordinate, we should be able to get this one because it's gone to the right by the same amount. So that's 0.87. This is also 0.87. And then instead of going up by 0.5, this has gone down by 0.5. So it's not 0.5, it's negative 0.5. Does that make sense? And now what this tells us, because that's now gone from 360 down by 30, so that's now the angle 330, what we are now saying is that it means that cos of 330 is 0.87 and sine of 330 is negative 0.5. And you should be able to then get the same, but that triangle there is a reflection of that one, and same with this. So reflections, you can get all of those coordinates. Then you can do the same for the others. So you should be able to fill this whole table out, circle out, without using your calculator, except for 45, just do that. But again, that one is a reflection of that one, and so on. Okay? And then what you're going to do is you're going to go through and graph plot all of your sine values. Okay, so all of these ones, and that corresponds. So this one here, sine of 0 is 0. That's why we've got this dot here. Sine of 30 is 0.5. So that's why we go 30 and then 0.5. You can plot the 45 if you want, haven't got on there. Sine of 60, that will actually be 0.87. So 60.87, it's probably there. That was a poor diagram by me. So that's 0.9, 0.87 will be here. Right, then we come over here and you'll see that that has the same height. So 120 would also be 0.87. And you might see some symmetry happening. And once you're done, you have to connect the dots, but with smooth hand. All the way to 360, please. Seeing here is that as you are plotting all of your y values, so that's your sine points, okay? So sine of 150 is minus 0.5. So here's 150. I'd have to go down to minus 0.5 and put the dot there. Oh, that's looking a bit dodgy. It's not minus, it's positive 0.5. There you go. That's why it didn't look dodgy. Okay, and at 180, what's your sign here? 0. Once again, because it hasn't gone up or down, so that becomes 0. So you get to connect the dots and make it a smooth curve. Psst, psst. What you are actually doing is you are plotting the height here. So as you are traveling, Matt, as you are traveling around a circle, we are plotting, the sine graph plots the vertical height. What is going to happen is we're looking at the sine graph, Tom, and what's happening is as this particle is moving around the circle, it is plotting the height. Okay? So as this particle moves around, what's happening to that height as it goes? You can't really see those at home. As this goes around here, can you see as it gets closer and closer here, what's happening to the height? it's getting higher and higher. And then as it goes past here, what's happening to the height? It's going down, and then as it passes here, the height becomes negative till it gets to a minimum of -1, and then it goes up again, okay? So watch it as it moves around. This is the second time I'm recording this now because it didn't play before, but we're basically, this is what you're doing on your worksheet when you're plotting your sine graph, is you're plotting as this particle is moving around, it's plotting the vertical height. Play. If we get to, oh, that's a bit nutty. Okay, so as it's moving around the circle, you can see that it's plotting the vertical height. So it's going negative, now it's getting bigger, it's going a maximum up to 1, and then as it goes down, so you can see. It's easier for me to do it here, but when I pause that, it pauses the video, so sorry. Anyway, so that it just keeps going and going, and on your graph, you would have plotted here from 0 to 360, and it just keeps repeating and repeating in laps, and it could keep going and going this way, and obviously the next. People were going, let's do cosine, and we wanted to start it at 0. We reckon it's going to start, so cosine is your vertical height, right? So over here at 0, it's going to have a vertical height of 1, and then as the particle moves around the circle, that 1 is going to get smaller and smaller and smaller until it is 0. Okay, so we're going to get here, it's going to start at 1. Let's see if we can catch it right on. Should get Eden to come up and do it. Oh yeah, that was pretty good. Eden said go. So you can see it starts at 1, it goes smaller, it comes up. Right. Anyway, goes too quick. I need to work out how to slow it down. So on your sheet that is on OneNote, if you got that, or when you come back, we can send it to you. We were plotting, and we said just plot the sine. Don't worry about plotting the cosine as well. Next lesson, we'll look at the tan. We just pressed that in class before, and everyone's going, why? So we'll save that for next lesson. Hope that wasn't too crazy.